So this is the last section in chapter 16, okay? So let's go ahead and copy the essential question. How can you show that two triangles are similar? Very easy stuff and also exciting stuff. So over here, of course, I want you to go through the whole textbook, but let me just go ahead and summarize for you. Basically, if you scroll down, you can see the many different things, okay? Here's AA similarity, and then there's also SSS and SAS triangle similarity. Okay, so those are the things that you are going to be learning today. And in case you don't understand, what is AA similarity? So we talked about similarity. We talked about when we have a shape and then we dilate it. When we dilate it, that means we're going to multiply the x and the y by the same number. It could be like 3x and 3y. But when we multiply the x and the y by the same number, that basically means this small shape is going to blow up into something bigger by 3. 1, 2. So now this little triangle has now blown up to this big triangle. And so now we have dilated this small triangle into the bigger triangle, and that means that these two triangles are similar to each other. So we already know all this stuff, but there's other ways to learn if two triangles are similar to each other or not. And AA similarity, without knowing whether they have been dilated or not, it just basically says if we have two triangles like this and we know that this angle is the same as, of course, that angle, because it's kind of like having the same two triangles on top of each other, right? So if I put the little triangle over here, you already know that the little angle here and the little angle here for the big triangle, they measure the same because of the reflexive property. But at the same time, if we know that this angle over here and this angle over here measure the same, then wouldn't we know for sure that this angle and that angle measure the same? Yeah, because of the triangle sum theorem. The black one and the red one measure the same, and so the blue one has to be 180 minus the black and the red, right? So therefore, if we have three angles that measure the same, then we know that the sides can be proportional, right? So therefore, that is what AA similarity is. If you have two triangles and two angles measure the same, so I'll have to take away the blue one. Oops, that was a big eraser. Anyhow, if you have two angles that measure the same, then the two triangles are similar to each other. Okay, and that's basically what they are teaching you over on this page. Please make sure you scroll down and learn all that stuff. As you can see, I did everything. There aren't any mistakes that I can tell. So then over here, it attempts to prove why the angle-angle triangle similarity theorem works. Okay, so it says prove it. And then first they're going to apply the dilation, and then you have to go through all these steps. Okay, and then you can actually prove it. Okay, but proving that is important, but the even more important part is being able to solve a problem for it, right? Okay. So now let's take a look. It says, is triangle ABC similar to DBE? Okay. If so, find BE. So BE is the last two letters here, so that goes with what? BC, because we already talked about this alien symbols. Remember, if I have ABC and triangle DBE, I talked about how I go boop boop, these two go together, and then boop boop, these two go together, and then dot dot, these two go together, right? So the BE and the BC is the bottom line over there, right? So they go together. So that's the first thing that we have to know. And so then I have to look for some other sides where I could see measures. So I'm just gonna go ahead and draw the line. BC is this one in blue. And then BE is this other blue line, okay? So now I have to find another side, and I'm going to use the color yellow. So this is the only side in the smaller triangle where I see a number, okay? So then where's AB? Oh, that's the first two letters. I hope you can see that. So then that will go with what? The first two letters in the second triangle as well, which is segment DB. DB, oh, so that would be this one right here. Okay, so now we can go ahead and set up an equation. This is very similar to what we did in class, right? So there you go. Let's go ahead and do this. BC over BE. BC is 42. So 42 over BE, and that's what we need to find. So that's going to be X. And that equals what? The ratio is, now we're going to look at AB, and AB is 28. So that has to go on top because we're doing small triangle over big triangle, okay? So 28 goes on top, and then DB. Where's DB? This other yellow line, and that is 42. And from here, we do exactly the same thing we did on the boards. Multiply like this, cross multiply. So 42 times 42 equals 28 times X. From here, it's pretty easy. You gotta divide both sides by 28. So X is now equal to, let's see, they can both be divided by 7. And then they can both be divided by 2. And 2 can go into 42 21 times. So 3 times 21 is 63. And guys, I don't want you to get confused over this, because you can just go ahead and multiply 42 times 42 divided by 28, and you'll get 63 right away. But I just didn't want to use a calculator, so I did all these reduction stuff, okay? Don't get confused. So your answer is 63. So let's see if that is correct. Yeah, it is 63. Okay, so I hope you can go through all of this and try and understand what I just did. But anyway, now is my favorite part, the homework section. As you can see, I have already solved both of them. So let me go ahead and show you how I did it though. Okay, so this is the first homework question, and it says find PQ if possible. So then you know what I like to do. Whenever I have to find something, I highlight it. So that's PQ because that's what I have to find. All right. So then let's see. Oh, what kind of similarity is this one? Hey, if this is a straight line and this is 90 degrees, do you think that means this is 90 degrees too? Yeah. So I'm going to go ahead and notate that because now I know that this angle and that angle measure the same. But what else did they give me? Oh, they told me that this angle and this angle is the same. How do I know this? Because they're marked in red and it's the same marker. Like, it's either just one line. If you want to say that this angle is the same as this angle, now it's going to be 2 lines. Okay? But anyhow, so that's how I know. So then, since this angle and that angle measure the same, and this angle and this angle measure the same, do you think that the 2 triangles are similar to each other? Yes, they are. And why are they similar? Because of the AA similarity theorem. Okay, so now that we know that these 2 triangles are similar to each other, we know that we can dilate the small triangle and it would fit into the bigger triangle. So what we have to do now is write down the names of the triangle. Okay, so then the small one, let's say I want to start off with the small angle T, and then go to the unmarked angle, which is Q, and then go down to the 90-degree angle, which is S. That's gonna be similar to the other triangle, and so you gotta use the same pattern. T was the one that was marked like this, so then I have to start with P because that's the one marked like that. And then Q was the unmarked one, so in this triangle I have to go to R because that's the unmarked one. And finally S because that's the 90-degree angle. So then if I want to find PQ, there's no way I can find PQ, right? So what that basically means is I gotta find out how long this whole thing is, which is PS. Okay, so then let me just go ahead and draw some lines. PS. Oh, those are the dots, the PS. Okay, so then that would obviously go with TS. Okay, so then what are some other sections that we are finding? So then let me just highlight that section so you know. TS goes with PS. These are the 2 sides that we're comparing. So now we want to compare some other side, and I'm looking at this triangle, so this one is 27. The only other side that I have that has a measurement is QS, okay? So what is QS? Those two. So then that would go with RS. So this is QS. Oh, that was black, so, but still. Okay, here's QS, and then RS. There you go. So these are the two sides that we are going to be comparing, all right? So let's do this now. So what was TS anyway? TS is 27 over PS. PS is obviously, because we're trying to find this part over here, that would be X plus 9, okay? X plus 9. And that equals, okay, we just did the dots, right? So let's do the lines. QS. Where is QS? QS is here, and that's a 9 over, what's RS? RS is 12. Okay, so we gotta cross multiply again, but before we do that, to make it easier, can we simplify 9 over 12? Yes, we can divide the top and the bottom by 3, and so that would actually give me 3 over 4, right? So let me go ahead and make it simple and put 3 over 4 over here instead of 9 over 12, okay? Because the ratios of the corresponding segments have to be the same. So we don't have to put the exact measure. If it's simplified form, just a ratio, that's good enough. So now let's go ahead and cross multiply. So 27 times 4 is equal to x plus 9 times 3. Or 3 times x plus 9, same thing. So when you multiply, it's going to be 108, and that's 3x plus 27. I subtract 27 from both sides. I got no space, so I'm gonna go here. So that would be 81, and that equals 3x. I divide 3 from both sides, and x is now equal to 27, and that's how I got it. All right? So moving on to the next homework question. Again, this question is rather easy because they told us straight out from the beginning that the triangles are similar to each other. We don't have to even think about, you know, how they are similar, okay? And then it just says find AB. What is AB? This whole thing. Okay, I meant to use a highlighter. This whole thing is what we have to find, okay? So then, how can we do that? So AED is this small triangle and ACB is this big triangle, okay? So obviously I can see two sides, this one and this one, and they both have a measure, okay? And then we can definitely use this side. The whole long side, I don't know, but then just from A to D, you can see is 6 feet, okay? So then for this one, we don't even have to use the letters, but let's just do it. AD is boing, boing, AD, okay? So that goes with AB. So AD, this short line over here, goes with the whole thing, AB, okay? And then let's see, ED is this line over there, that goes with CB, okay? So obviously you can already visualize which numbers you gotta use. So AD is the whole thing, which is X over AB. Oh shoot, I'm sorry. AD is the short thing. The short thing is 6 over, and then AB, and AB is the whole long thing that we're trying to figure out, right? And that's supposed to equal ED, and ED is 9, and then CB, which is 39. So then from here, again, too easy, just cross multiply. So when you divide both sides by 9, you'll find out that the answer is 26, because 6 times 39 is, I don't know, some random big number, and then you divide by 9 and you'll get 26, and that is the correct answer. And now if you go into the next section, you would see that over here they're talking about SSS and SAS triangle similarity. Basically what that means is given to you right here. But it says if you have three sides of a triangle, and if those sides are proportional to the corresponding sides of another triangle, basically that means I have two triangles. And then I find out that this side is 1, 1, and 1, and this side is 3, 3, and 3. Well, what is the ratio for me to go from small to big? 1/3, or just 3, but okay. And then what's the ratio for this to that? 1/3. What about this to that? 1/3. Are they all the same? Yes. So if the ratio of all three sides in both triangles are the same, if the proportions are the same, right? Then the two triangles are similar to each other, and we call it the side-side-side triangle similarity theorem. And we already know this because we know about dilation. When we dilate this triangle, what are we doing? We're multiplying everything by 3, right? So we already know that we blew this up by 3, and so we know that these are the same shape, but just bigger, different size. So knowing the definition of dilation, we already know that they are similar, but we also just have another name of understanding how they are similar to each other. Same thing over here, side, angle, side. So we have two triangles, and we need to have like two side lengths that are proportional to each other. So 1/3, 1/3, 1 to 3, and 1 to 3. And then the angle in the middle, the angle in between the two sides. That's why the angle is stuck between the two sides, okay? That's why it's called SAS. And these two angles measure the same. Then we can say that these two triangles measure the same. And we already know this because it will be kind of like this. We have a triangle right here, and then we just blew it up, and then it just got bigger like that, okay? So then that makes sense because the angle right here is kind of like separating these two triangles. So these two angles measure the same, right? Anyway, even if you didn't understand it, it's okay because the proving by dilation is much easier to do. But anyhow, let's take a look at this question over here. It says, are they similar to each other? And so the answer is yes, it is similar to each other, and we are using SSS. But you'll be like, Miss Choi, but this is not SSS because we have this side, but we don't know how long this is. We have this side and that side, but we don't know how long this is. But you see, guys, this is where we have to use our brains a little bit. This is a 90-degree angle, which means this is a right triangle. So how can we find the measure of this side over here? Using the Pythagorean theorem, remember? So what you're going to do is say 50 squared is equal to 48 squared plus NO squared. Okay, because that's this side. So then, using that, you can go ahead and figure out how long this side is, okay? And I'm going to just actually calculate this for you. 48 times 48. I'm going to whip out my calculator because I can't do it in my head that fast. So that's 2304 plus NO squared. So to find NO squared, I got to subtract 2304 from there. And so I get 196, and that is NO squared. But I don't want to know what NO squared is. I want to know what NO is. So find the square root of both sides, and so NO is equal to, what is 190? What is the square root of 196? That will be 14. So this side is 14. Okay, now you gotta find how long GH is, and you can use the same thing, Pythagorean theorem. Okay, so for this one, 25 squared is equal to 7 squared plus GH squared, right? So 25 times 25, I know this one is 625, 49 plus GH squared. So let's subtract 49. And that's 576. Oh no, why is my pen not working? There you go. 576, and that equals GH squared. So if you find the square root of both sides, okay, GH is going to be Let's see, I need a calculator for that. 24. Okay, so then I have the length of this side. So now you can see how it's an SSS triangle similarity theorem, because look, 7 times 2 is 14, and then 24 times 2 is 48, and then 25 times 2 is 50. The ratio is the same. Basically, this is twice as big as this little triangle, or if you want to go from the big to the small, basically the big one, this one is half the size of the big one. So anyhow, MNO is similar to GHJ by the SSS. We cannot use SAS because you have SS and then an angle. The angle has to be right smack in the middle. I'm going to stop the video here. I just wanted to let you know that for this section, any of the first 18 questions can show up, because I looked at every single question, especially this one I like the most. But every single question is a really good question. So I need you to really work on every single question over here, all the way up to question number 18 in lesson 16.4 to prepare for the test. I hope everybody goes to the boards and asks me questions. Happy learning!